Minutes here, let me give you a quick bit of information, and this is just a nice review of the types of compounds that we've kind of talked about so far, but specifically in terms of how solids are different. Okay? Molecular, ionic, and atomic. So made of, that's what sort of the individual units of the solid are. Okay, when you have a solid, you have things all stacked up. Okay, but what are the individual units? Well, they're molecules. Here, they're ions. Right? But the ions are alternating. Right? They go like plus, minus, plus, minus, minus, plus, minus, plus, and so on. Okay? Where molecules are all of the same kind of groups of atoms, okay? And they're just all stacked up the same way. Okay? What kind of elements make up molecules? What kind of elements, though? From what part of the periodic table? Nonmetals only. That's good. Okay. Whereas if we had an ionic compound, that would usually contain a what and a what? Metal and a non-metal. Okay? But be careful if there are polyatomic ions. Okay? We could have a polyatomic ion like NH4 plus and something like NO3 minus, which technically that's all non-metals, but it's just that much more important that you can still recognize polyatomic ions. Okay? That if you have a positive, if you can identify any way a positive and negative ion, that's an ionic compound. Okay? Now when I say held together by, I'm talking about what is keeping these units together as a solid. Okay? So for instance, the simplest way I could draw a solid of water is I'm going to draw 3 H2O molecules. There has to be something holding them together, otherwise they would just fly away as water vapor. So what did we call these in between those water molecules? IMFs. Right. And there are actually 3 intermolecular forces. There's the dispersion, dipole, dipole, just like we talked about, and H bonding. Okay. But it's different what holds ionic compounds together, right? Those we called ionic bonds because we had something like an Na with a plus charge attracted to a Cl with a minus charge, totally because they have opposite charges. Okay. So, and when I say charges here, all of these attractive forces come from charges in one way or another. It's just they're laid out a little bit differently, right? In any case, when we have a molecule, intermolecular forces are always made up by partial charges sort of inside of the molecule. Whether that's permanent or temporary, or whether those are strong or weak, okay, that's a matter of the types over here. But you'll notice in each of those types, okay, we had intermolecular forces pulling those partial charges, those opposite partial charges on opposite ends of those molecules. Okay? But over here in ionic, these are full charges. Okay? Where sodium totally lost an electron and that chlorine totally gained an extra electron. Okay? So what do you think is going to be a stronger interaction? The attraction of these partial charges in those molecules, or the attractions of the full charges between those ions? What's going to be stronger? Yeah, full charges are going to be stronger. So melting point of molecular substances are usually pretty low, right? In general, under 200 C, let's say lower than ionic at least, where ionic compounds have very high melting points. Because in order to melt a solid, you have to get its particles, its groups moving, okay, out of that general structure. Okay? And that's easier to do in molecules because it's just intermolecular forces. That's actually very difficult to do with these very strong attractions of opposite charges like that. Okay? So the last group is atomic solids. I'm going to say those are just atoms. Okay? I have a little bit about 3 types of atomic solids on the back page of this. You can probably figure that out for the most part. If you run into something like that on the Mastering Chemistry, check the textbook about atomic solids, and I'll also have this last page, just a couple little pieces of information on this last page of the notes in the completed notes in the content area, if you want to look at that too. Okay? But that might just be one question in the Mastering Chemistry. Okay? So I think we're good. I will see you all in lab. Don't forget the Mastering Chemistry and then the exam.